We're going to look through the second half of lesson 2, the end behavior of polynomials. So what the end behavior of polynomials is referring to is what is the graph doing if we follow it indefinitely in the horizontal direction. So let's take a look at this first graph to the left. It's telling me as I look to the left, right? That's what this is saying. As x goes to negative infinity, as we continue to look left, where does the function f of x go? So now we're looking on the graph. Let's see. So we're following it as we look left, as we look left. Where's the graph going? It's continuing to go up. So if I'm thinking about y and I want to write that y continues to go up, that means y is going to continue to get bigger and bigger, more and more positive as it approaches positive infinity. So as we're describing this left side of the graph, x approaching negative infinity describes looking left, while f of x goes to infinity, that describes going up. So the left side of this graph goes up. Now let's look at the other side. So as we look as x approaches infinity, so that means as x gets more and more positive, the right side of this graph, what is the function doing? The function as we go to the right is also going up. So let's see. This means right, x approaches positive infinity, f of x is getting more and more positive. So for any even degree polynomial, which is what this quadratic represents, this parabola, we have even degree and a leading coefficient that is positive. That's going to end up with both ends going up. So if you recall from yesterday, a positive leading coefficient really relates to the right side. So if it's positive, the right side is going to go up. And the even degree tells us that both ends are going to go in the same direction. So if the right side goes up, the left side goes up. And then this notation down here is a formal way of writing that the left and right side are going up. Let's stick with even degree and then transition to what happens if the leading coefficient is negative. So now we're going to look down here. So we're still even degree, but now the leading coefficient is negative, which means this right side is going to go down. And because it's still even degree, they're both going to go down. So let's see how we can write that. So as we look horizontal, let's start by looking on the left side. Again, as x gets more and more negative, as we look to the left side of this graph, the function on the left is going down. So how do I describe that? Well, if y continues to get more and more, as y continues to get smaller, goes down, gets more and more negative, it's approaching negative infinity. So again, this means as I'm looking left on this graph, what is the function doing? It's going down. Okay, now let's look at the other side. As we look to the right, as x gets more and more positive, what is this graph doing? So I'm looking right, but really my graph's over here. So as I look to the right side, it's also going down. So my function f of x is going down towards negative infinity as we look to the right. So as x approaches infinity, f of x approaches negative infinity. Should also notice here that for both of these notations with our end behavior, both of our y's, our f of x's, are going in the same direction, right? So this one, when we had a positive leading coefficient, f of x went to positive infinity, f of x went to positive infinity because we have an even degree polynomial. As we look left, as we look right, f of x goes up, up on both sides. Here we have an even degree, and f of x is going down to negative infinity on both sides because as we look left and we look right, both ends are going down, but still the f of x's are going towards the same value because it's even. Okay, let's take a look now at the odd degree polynomial. So first we'll start with a positive leading coefficient. So as the leading coefficient is positive, again, that refers to just the right side of the graph. That means the right side goes up. And once we know we're looking at an odd degree polynomial, the ends are going to behave opposite. So the left side is going to go down. So let's see how we would write that. So as we look left on this graph, as we look to the left, what's my function doing? My function's going down. So how do I describe that? F of x is going towards negative infinity as x approaches negative infinity. They're both getting more and more negative, smaller and smaller x as you look left, smaller and smaller y's because the function is going down. Now let's look the other way. As we look to the right, which means I'm looking on this side of the curve, where's my function going on the right? It's going up. So as I look right, f of x is going up. So right, x is approaching infinity, getting more and more positive. F of x is going up, which means y is also getting more and more positive, going towards positive infinity. So you'll also notice here we have an odd polynomial, and both of these functions, my notation, they're both going towards opposite infinities because we're dealing with an odd polynomial. Okay, and then let's take a look at our last scenario. So now we have a leading coefficient that's a negative. As soon as we know that leading coefficient is negative, the right side we know is going to go down on our graph. And because we're still in the category of odd degree, that means they're going to be opposite. So the left side's going to go up. So as we look to the left, we look horizontally left on the curve. What's the left side of the graph doing? It's going up. So as x gets smaller and smaller, as we look left, as x approaches negative infinity, what is f of x doing? The y values are getting bigger and bigger. They're going up, so the y is approaching infinity. And then other side, as x approaches positive infinity, as we look to the right side of this curve, what is the function doing? The function's going down. So f of x is going down and getting smaller and smaller while we look to the right as x gets bigger and bigger. So f of x is approaching negative infinity. And again, if you look at this end behavior notation, you should notice again that my f of x's are going towards two different infinities since they're going in opposite directions, since this is an odd polynomial. And these are the four scenarios of end behavior for polynomial functions. It's always going to end up in one of these four categories, depending on the degree and the sign of the leading coefficient. So now what I'd like you to do is turn the page in your notes and take a look at exercise 1. I'm going to ask that you read the directions. You have two different graphs here, and I'm asking you to determine just by looking at the graphs whether you're looking at an even or odd polynomial function, what you think the sign of the leading coefficient would be, positive or negative, and then can you state that end behavior notation we just worked on in the graphs above. So just pause the video, give this a try, and then press play and we'll go over it together. Okay, so for this first one, we're looking at whether or not this polynomial is even or odd degree. So let's take a look. My ends are going in the same direction. So since both ends are pointing up, that automatically means I have even degree, right? Even is if they both point in the same direction, either both up or both down. When we want to know the sign of the leading coefficient, we focus right in on just the right end. And since the right end is going up, that tells me the sign of the leading coefficient, should be positive. So even though we don't have the equation of this polynomial function, we know that the highest degree in standard form of the term would be an even degree, and we know that the number in front of that term would be positive. And now let's state that end behavior. So we're going to say as x goes to negative infinity, that's the left, f of x is going towards, so let's again remember the left side. So as we go to the left, my function's going more and more up, so f of x is going to positive infinity. And as I look to the right, as x gets more and more positive, my function is continuing to go up as well on the right. As we look right, we go up, up, up. That's also positive infinity. So if you're asked to state end behavior, this is what we're asking of you, to state these two sentences. Describe what's happening on the left, describe what's happening on the right. Okay, so now let's look at the second graph. So what is the degree here? Well, I can already see that I have opposite behavior. One end is going up, one end is going down. So that automatically means I'm dealing with an odd degree polynomial because of the opposite behavior of my ends. And then when we want to talk about the sign of the leading coefficient, we go right to the right side. Since the right side is going down, we know that must be a negative leading coefficient. And then the end behavior, you can always kind of start it the same for x because we're always going to look horizontally in both directions. So as x goes to negative infinity, as x goes to positive infinity, what is my function approaching? So let's start with the left side. As we look left, I can see my function is going up. So that means my y's are getting bigger and bigger, approaching positive infinity. As we look on the right, my graph is going down. The y's are getting smaller and smaller, so the function is approaching negative infinity. Okay, so now let's take a look at number 2. Similar directions as number 1, but what I'd like you to do is now take a look at these. Just start with 2a and 2b and take a moment to look at those two standard form polynomial equations, state the degree, state the sign of the leading coefficient, and state what the end behavior is. Now we don't have a picture of the graph, but we're imagining what the graph would look like based on the same two pieces of information, the degree and the sign of the leading coefficient. And then I want you to just pause the video, just try parts A and B first. Okay, so hopefully you've taken a minute to identify these things. So let's take a look at part A. Part A, not in standard form, so I should be identifying that x to the third is really my leading term. So that gives me a degree that is odd. Really, specifically, it's a third degree polynomial, which is an odd degree. And the sign of the leading coefficient there, well, it's a positive 1, so that's a positive sign, a positive 1. So without stating the end behavior yet, let's just imagine what the ends are doing. So if the sign of the leading coefficient is positive, that means the right end of this graph is going to go up. So I'm just going to draw an up arrow representing the right side. And if the degree is odd, that means they're going to go in an opposite direction. So the left side automatically I know is going to go down. So even though I don't have a picture of this graph, I know that the left end is going to go down and the right end is going to go up based on the degree and the sign of the leading coefficient. So now let's go back to the end behavior. So as x goes to negative infinity, so right now I'm just talking about the left side. And if we want to, like, let's look over here. This is what I'm referring to. So as x goes to negative infinity, we know that the left side's going to go down. So that means f of x is also going to go towards negative infinity. So on the left side, everything's getting smaller. X is getting smaller, y is getting smaller. And as we look to the right, as x gets more and more positive, let's take a look here. The right side's going up. So how do I describe that? Well, as x gets bigger and bigger, y gets bigger and bigger, f of x is going to positive infinity. So sometimes when you don't have a graph to visually look at the arrows, just drawing in the left and right arrow is like a nice helpful step before you state the end behavior. So now let's take a look at number 2b. So again, not in standard form, so I'm looking at the negative x squared as my leading term, and that is an even, right? That would be a quadratic or a second degree. You don't have to write the number. I'm just kind of confirming why it's even, because we have a degree of 2, and the sign there is negative. Negative 1 is the leading coefficient of that x squared term. So once I know the sign of the leading coefficient is negative, my right side's going to go down. And because this is even in degree, they're both going to go down. So the left side would also go down. So now let's describe left to right. So first, the left side, What's that going to look like? Well, as x goes to negative infinity, meaning we look to the left side, the function is also going to go towards negative infinity since it's getting smaller and smaller. The y's are going down. And then as x goes to positive infinity, right now we're looking the other way. Now we're looking right. My arrow's also pointing down, so f of x is also going to go towards negative infinity. Okay, and then for these last two, I had you kind of pause and not start them yet because this is a little bit different in the way the polynomial equation is being given to us. Now we're looking at a factored form of our polynomial. So here, A and B were both standard polynomial form. Well, not exactly, but we could have written them in standard form, right? We could have rearranged f of x in standard form would have been x cubed plus 10x squared plus 32x plus 34. And then f of x in part b would have been negative x squared minus 8x minus 15. So we could have written them in standard form. But standard form is when you're looking at a series of terms being added or subtracted. Highest exponent term should be first in descending order to the constant. But everything's based on that first term. Highest power degree of that term and the leading coefficient of that term. When you're in factored form, we have to just approach how we look at the function a little bit differently. Now, we're not going to stay here and multiply this all out because that would just be a little bit of a waste of our time when our goal is, again, just to kind of identify these two things, degree and the sign of the leading coefficient. So looking at part C, what I want you to imagine is if you took this x minus 3, we have one factor of that, two factors of x plus 2, and one factor of x minus 5. If we imagined multiplying it out, like for instance, if you imagined multiplying out x plus 2 squared, not that we're going to do this, but you would end up with an x squared, right? You'd have other terms, but x's highest power would be a 2. Then if you multiplied that with the x minus 3, right now your x squared becomes an x cubed. And then if you multiply that with the x minus 5, now that x cubed becomes an x to the 4th. So what you can do to identify the degree when you're looking in factored form, which is, a different way of looking at the polynomial equation, is you're going to identify what are the degrees of each of our factors. So here we have x minus 3 to the first, not degree, but really what is the exponent. So we have one factor of x minus 3. We have two factors of x plus 2, and we have one factor of x minus 1. So when I'm thinking about the degree, I'm going to actually just take them and think about multiplying out x's. When you multiply x's together, you add their exponents. So if I were to multiply this out, I would add up the powers of 1, 2, and 1, and I would get a 4. So this would end up being an even degree polynomial because it would end up being a 4th degree. Now, the sign of the leading coefficient just really comes down to what's in front of the factors. All of these x's are positive, 1 in front. So if I did multiply all that out and the number in front of all the factors is also a positive 1, looking at that first line of those factors, I can see that all I would get is a positive 1 for that leading coefficient. So we have a positive leading coefficient with an even degree polynomial for part C. So even though we didn't multiply this out, we now know that the right side of this graph would go up because the leading coefficient is positive, and because it's even in degree, the left side would go with it. So let's take a moment to write this out. All right, so I have my end behavior as x goes to negative infinity. My function is going to go towards infinity, and as x goes to positive infinity, the right side, my function is also going to positive infinity. So now we know what this graph, the ends of this graph is doing, again, by just looking at its factored form. And then we have one more factored form for part D. So let's start by looking at those powers. So we have negative x squared, so that's two factors of x, two factors of x plus 7, and then one factor of x minus 1. So if I think about the degree, If I multiplied this out, I have 2 factors plus 2 factors plus 1. The degree would add up to a 5th degree polynomial, which is odd, right? A 5th degree. If you were to multiply that out, x's highest power would be a 5. And now I can also see the leading coefficient here has a negative in front, right? If I took this positive 1x, this positive 1x, and multiplied it with this negative x, that would end up with a negative in front. So if you want to pause the video for a moment, take the odd degree and the negative sign of the leading coefficient and see if you can write the end behavior this last time. Okay, so we have a negative leading coefficient, right side's going to go down, odd degree, so they're going to go opposite. If I look at just the left side first, and I want to describe that more formally, that means as x is going left, so as x gets smaller, what is f of x doing? Well, that arrow is pointing up, so f of x is going to infinity. And as x goes to the right, as x gets bigger and bigger, so positive infinity is what x is approaching on the right side, my arrow is pointing down, so f of x would approach negative infinity. So this summary in the bottom here just really describes those 4 possibilities. So you have an even degree, both ends either could go up, both ends could go down. How do you determine that? Well, again, that right side, if the leading coefficient is positive, that right side's going to go up. If that leading coefficient is negative, that right side's going to go down. And when they're even, they have to go together. And then same thing for odd. If we're dealing with an odd polynomial, that means that based on the leading coefficient, if the right side's going up because the leading coefficient's positive, the left side's going to go down because they have to go opposite, right? So that would be the right side going up, left side going down because they're odd in degree. And if it's a negative leading coefficient and the degree is odd, the right side's going to go down because the leading coefficient's negative, the left side's going to go up because we're odd in our degree. There are several activities for you to now try in the notes for lesson 2. I'd like you to please go through each activity, and the answer key to this lesson will post on Canvas at the end of the school day.